Boeing ran hundreds of thruster tests, and every single one passed because every single one was run in the wrong environment. That sentence sounds like an accusation. It isn't. It's a physics problem that Boeing walked into one green test result at a time. And the engineers who signed off on those tests weren't incompetent, they were confident. That confidence was the trap. June 2024. Boeing's Starliner capsule clears the launch tower carrying two NASA astronauts, Butch Wilmore and Suni Williams, on what Boeing's mission timeline listed as an 8-day shakedown flight. The plan was clean: dock with the International Space Station, run through the checkout procedures, bring the crew home. 8 days. Boeing had spent years building toward this moment. The thrusters had been hot fire tested, the systems had been signed off, the capsule was ready. The first thruster shut down before Starliner even finished its docking approach. Then a second, then a third, fourth, fifth. 5 thrusters going dark in sequence during the approach to the station. 5 thrusters, which means the crew briefly had no reliable way to steer in 3 separate directions at once. Ground teams scrambled. Engineers pulled up test records. Every record said the same thing. The thrusters had passed every single test, green across the board. The hardware was not supposed to be doing this. Here's what the hardware was actually doing and why no Earth-based test could have predicted it. Starliner's thrusters don't sit exposed in open space. They live inside a metal enclosure, a closed housing the Boeing engineers called the doghouse. It's a compact box. Several engines share it. During the docking approach, those engines fire repeatedly in short bursts over and over as the capsule corrects its position. Each firing produces heat. The heat has to go somewhere. On Earth, that's never a problem. Heat spreads 3 ways: through the metal around the engine, through the air in contact with the engine, and outward as invisible radiation. 3 exits. The box stays manageable. The tests always passed. In space, there is no air. One of those 3 exits vanishes the moment you leave the atmosphere. The box still produces the same heat from the same engines doing the same work, but now the heat has only 2 exits instead of 3. It builds. The metal box cooks itself from the inside, slowly, firing by firing, approach maneuver by approach maneuver. Picture a car engine that runs perfectly in a garage with a cooling fan blowing directly on it. Take the fan away and drive the car hard on a highway. The engine seizes, not because anything broke, not because the engine was designed wrong, because the fan was doing the cooling the whole time, and nobody noticed because the fan was always there. Boeing's Earth atmosphere was that fan. It was silently carrying heat away from every test stand, every hot fire run, every endurance check. The tests passed because the atmosphere was quietly helping. The atmosphere doesn't come with the spacecraft. Inside that overheating enclosure, the temperature climbed past what the fuel valve seals could handle. The seals are made of a material similar to Teflon, a soft compound chosen for chemical compatibility with the propellant and for its flexibility under pressure. When temperature goes high enough, well past the temperature of boiling water, approaching temperatures that would melt solder, that material swells. It deforms. A swollen seal no longer lets fuel flow cleanly through the valve. It blocks. When fuel flow drops below the level the thruster's own onboard computer expects, the computer does exactly what it was designed to do. It shuts the engine off. Automatically. No override, no warning. Just a shutdown flag and a dead thruster. 4 of the 5 failed thrusters were eventually brought back online through in-flight troubleshooting. Careful resets, slow restarts, engineers on the ground working through the problem in real time while the crew held position near the station. The 5th stayed dead. 1 thruster, permanently lost to a seal that had swollen past recovery, inside a box that the testing program had never actually stressed the way space stressed it. The thruster failures were not the only system reporting problems. 7 out of 8 helium seals in Starliner's propulsion system began leaking during the mission. Helium is the pressurizing gas. It pushes the propellant through the lines and into the thrusters. Lose helium pressure and the engines don't fire at the right force or don't fire at all. The leading explanation from engineers: the seals were chemically incompatible with the fuel they were sitting in. Not visibly, not in short-term tests. The incompatibility showed up only after extended contact, days of immersion in actual propellant under actual spaceflight pressure conditions. Lab tests don't expose seals to propellant for days at flight pressure. They test for hours. They test at atmospheric pressure. Then they sign off. Then the seal sits in propellant for a week in space and begins to degrade from the inside out. The 8-day mission became 8 months. Wilmore and Williams remained aboard the International Space Station through summer, through fall, through winter. They didn't stay because of a mission change or a scheduling decision. They stayed because the vehicle that was supposed to bring them home had failed systems whose failure modes Boeing's test program had not been capable of detecting. NASA eventually classified the event as a Type A mishap, its highest severity rating, the same category used for events at the level of the Columbia disaster investigation. The crew survived. The classification still stands because survival doesn't retroactively change the nature of the failure. NASA's official language for what happened to Boeing's testing program is non-representative test conditions. That phrase does a lot of quiet work. What it means, stripped of engineering caution, is this: the tests were run in an environment that did not match the real environment. The results they produced were accurate for Earth. They were meaningless for space. Every passing grade on every ground test was a grade earned in the wrong classroom, on the wrong exam, for the wrong physics. The only real fix is to test inside a thermal vacuum chamber, a room-sized vessel that removes the air, replicates the thermal swings of actual orbit, and runs the exact firing sequences the hardware will face in space. Not a simulation, not an approximation, the actual pressure, the actual thermal environment, the actual duration. These chambers exist. They are slow and expensive to run, and many programs skip them or compress the test sequences to save budget and schedule. When you skip them, you are not skipping cost. You are deferring it. You are moving it forward in time to the moment the hardware first meets the environment it was never actually tested in. The fix Boeing needs for any future Starliner is not a mystery. Redesign the thruster enclosure so heat can escape. Give it vents, pathways, radiation surfaces that work in vacuum, not just in air. Replace the seal materials with compounds that don't react with the propellant over time. Run every test in a vacuum chamber that actually replicates space. These are known solutions. The reason they weren't already in place is not ignorance. It's the same confidence that makes every aerospace program vulnerable. The assumption that if a component survives every test you've run, it has survived the test that matters. It hadn't. It had survived the tests you were able to run. That's a smaller set than it looks like from the ground. Here is the part that doesn't go away easily. Boeing ran years of ground tests specifically to prove the thrusters were safe. The tests looked good. Every successful result made the design look more proven. That accumulated evidence made it less likely anyone would go back and question the testing methodology itself. The better the results, the more invisible the flaw became. The test data was not lying. It was telling the truth about a different environment, and no one was asking whether the two environments were the same.
This is not a Boeing problem. It is a physics problem, and it applies to every spacecraft ever built. Earth's atmosphere is an invisible engineering assistant. It manages heat, it buffers pressure changes, it keeps test environments within ranges that hardware can survive. When you send hardware into space, the assistant stays home. The hardware goes alone into an environment it has never actually been in. Every mission that skips true vacuum testing is trusting a result from a different world. Some of the time, the hardware survives anyway. Some of the time, it doesn't, and you find out when there are 2 people inside it 400 kilometers above the ground, with no way to drive back to the test stand and run it again. The thrusters passed every test Boeing ran. That's the complete, accurate statement. It just doesn't mean what it sounds like.